Welcome to a session on dispersive power of the material of a prism using spectrometer. Today's our aim of the experiment is to determine the dispersive power of the material of a given prism by using spectrometer. To do this experiment in our lab we are using the apparatus, spectrometer, glass prism and mercury vapor lamp which is kept inside the wooden box. So to do this experiment the formula is dispersive power omega is equal to mu2 minus mu1 by mu minus 1. Here mu1 and mu2 are the refractive indices of two different colors of our VIBGYOR spectrum and mu is the average of mu1 and mu2. To calculate this refractive index mu, here we are using the formula sin of a plus dm by 2 by sin a by 2. Here a is the angle of the prism. We are using glass prism. So any side is equilateral triangular shape, hence the angle of the prism we can take 60 degrees and dm refers to the angle of minimum deviation. So after doing this experiment at the end we will calculate this dm, angle of minimum deviation. Before going to start our explanation, so let me explain about the apparatus. Here there is a mercury vapor lamp which is kept inside the wooden box. So there is a spectrometer and we are using glass prism here. So when the white light passes through this glass prism, we can see the VIBGYOR colors with the help of this spectrometer. The spectrometer mainly contains three important parts. This is telescope and this is collimator and this is our prism table. So in the collimator you can have the slit which is placed in front of our mercury vapor lamp. So through that slit you can able to see the white light image with the help of telescope. This telescope is placed exactly parallel to our collimator. Now let us see our slit. To see the slit by using this collimator screw arrangement you can able to adjust that slit very narrow and with the help of the screw you can avoid the some kind of disturbances. Finally you can set the very narrow fine slit, white slit, so that you can able to see with the help of our telescope. After adjusting that slit with the help of collimator adjustments, now you can see the white very fine slit which is very clear, the vertical one, not the white spot here, the vertical line. Now we are going to coincide with the vertical cross line of our cross wire. After adjusting the vertical cross wire to the white light, now we need to calculate the direct reading of the slit. So to calculate the direct reading of the slit, we will use this formula, refractive index mu is equal to sin of a plus d by 2 by sin a by 2. See in this formula a we know it is 60 degrees. To calculate this angle of minimum deviation dm, we will follow this tabular column. So to calculate the dm, see angle of minimum deviation dm, so this is the tabular column. So it contains spectral lines, that means various colors in our VIBGYOR spectrum, and we have direct reading. This direct reading again contains two columns like vernier 1 and vernier 2. So to calculate this vernier 1 and vernier 2 with the help of our spectrometer, we need to note down first main scale reading, vernier coincidence and least count. So before going to explain about this, let me start with the least count. Least count of the spectrometer. So least count of the spectrometer is nothing but one main scale division by total number of divisions on the vernier scale. So let me explain about the least count. For that I am explaining the scales which are there on our spectrometer. So here you have vernier scale, the above one which contains 30 number of lines, and the below one is your main scale which can be measured in degrees. It contains totally 0 to 360 degrees. Now on this main scale, once if you observe the divisions, the difference between the 70 degrees to 80 degrees, you have 10 degrees totally which are subdivided with 20 number of lines. Hence one division on this main scale is equal to 0.5 degrees. That means 30 minutes. One division is equal to 0.5 degrees. If you convert into minutes, that value is equal to 30 minutes. Now to calculate the least count, one division on the main scale divided by total number of divisions on the vernier scale. So we know the one division on main scale, 0.5 degree, that means 30 minutes. The total number of divisions on the vernier scale is equal to 30. So now least count is equal to 30 minutes by 30. This is equal to 1 minute. So least count of the spectrometer is 1 minute. To calculate mu, we are calculating angle of minimum deviation. So to calculate that DM, you need to note down vernier 1 and vernier 2. So vernier 1 is nothing but MSR plus VC into LC. Main scale reading plus vernier coincidence into least count. Least count already we know, 1 minute. Now how to take this MSR and VC, I will explain you with the help of this figure. So here the main scale is started with 70 degrees. So now coming to the, we know no, each division on the main scale is 0.5 degree, half a degree. Now it is 70.5, 71, 71.5 degree, 72, 72.5. 73, 73.5 degree, 74, 74.5 degree, 75, like that you can able to count the number of lines on the main scale. Now how can you take the main scale reading, MSR? So see, the upper one vernier scale, 0th line is coinciding to exactly any one line on your main scale. So here as per this figure, now the 0th line of your vernier scale is coincided to 79.5 degrees. Here MSR is equal to 79.5 degrees. Now coming to vernier coincidence. To calculate the vernier coincidence, you need to concentrate on this upper portion of the scale. This is your vernier scale. Vernier scale contains already 30 lines. Amongst all these 30 lines, any one line must be coincided to any one line of your MSR, your main scale. So as per this figure, now you can see very clearly here my 12th line on the vernier scale is exactly coincided to any one division on my main scale reading. So here my vernier coincidence is 12 minutes. As per the above explanation, so I will once again I will tell you the MSR value is 79.5 degrees and vernier coincidence is 0, 5, 10, 11, 12, 12. We see vernier coincidence is 12. So to calculate the total vernier 1 or vernier 2, you need to take MSR plus VC into least count. So as per the above figure, the MSR reading is 79.5 degrees plus vernier coincidence is 12 into least count of the spectrometer 1 minute. So you need to add like this, 79.5 plus 12 minutes. So later I will explain you about this calculation. And in this experiment, throughout the experiment, the calculation of this MSR and VCs plays an important role. So far whatever we have explained on the figure, now that scales I am showing you in the spectrometer. So in the spectrometer prism table, so exactly to your position, your left hand and right hand side, you can find two scales. You can consider on left hand side vernier 1, right hand side vernier 2. Otherwise right hand side vernier 1, left hand side vernier 1. That is up to your wish. So now I am considering my LHS side vernier 1 and RHS side vernier 2. So I will show you again the vernier scale and main scales here. See, the upper one, the small scale which contains 30 number of lines is your vernier scale. The lower one, large scale, is your main scale. Now how to take this MSR and VC? Before that, now the spectrometer is arranged for direct slit position. That means both the collimeter and telescope are arranged on a straight line. Now this position is for to take the direct reading for a white slit. So after making the necessary adjustments, I am taking vernier 1. So for direct reading, I have directly adjusted vernier 1 for 0 degrees and vernier 2 for 180 degrees. This reading we call it as direct reading. So vernier 1 is for 0 and vernier 2 is for 180 degrees. So these are our direct readings for our white slit, exactly coincided. So this is our direct reading. The direct reading is common for all the colors. Now I am going to place the prism on the prism table. So when I am placing this, any one corner position must be coincided to your collimeter end. So in such a way, your rough surface of your prism must be either towards your right hand side or left hand side. Now my prism rough end will be on my right hand side. Now what will happen? This mercury light will falls on the prism. This white light is going to be split into VIBGYOR colors. So to see that VIBGYOR colors, with the help of this telescope you can able to observe. So to observe that VIBGYOR spectrum, you need to move this telescope towards your rough surface portion, rough surface end of your prism. Slowly you need to move the telescope until you see the VIBGYOR colors in the telescope. Yes, now I got the colors. Here I am showing you the VIBGYOR spectrum on the paper. So like this you will get the spectrum in the spectrometer: violet, indigo, blue, green, yellow, orange and red. So after getting the spectrum, you can go with any colors, how many you require. Here I am going with the blue, green and yellow colors. Firstly I will take the reading for blue color. So how to take the reading? For that I am using my eyepiece crosswire. That means by moving your telescope, you need to coincide your vertical crosswire exactly to your respective color. That means I coincided my vertical line of the crosswire to my blue color. So in this way you need to coincide it. See, now here in the real spectrum, with the help of the telescope, I have coincided my vertical cross wire to the blue color. See, now you can see very clearly the vertical cross wire is coincided to my blue color. So after coinciding the vertical cross line to the blue color in the spectrum, now you need to note down the readings for Vernier 1 and Vernier 2 in the spectrometer. For that, firstly you need to note down a main scale reading and Vernier coincidence. Now first see the main scale reading in the Vernier 1. See here, now you can observe for blue color we are taking the readings for MSR and VC. See, this is your Vernier scale 0. The 0th line of your Vernier scale is coincided to 39.5. See, this is 40. That means the scale is increasing like this. So the 0th line of your Vernier scale is coincided to 39.5 of your main scale. So now here the position for MSR is 39.5 degrees. So you need to write down MSR as 39.5. Now you need to calculate the Vernier coincidence. So here to calculate the Vernier coincidence, you need to observe your Vernier scale. On the Vernier scale totally you have 30. So in that 30, the 17th line is exactly coincided to any one line of your MSR. So this 17th line is the Vernier coincidence here. So 17 into least count is 1 minute. So the Vernier 1 is equal to MSR plus VC into LC. Now we are noting the readings for Vernier 2 for same blue color. So this is your V1 and coming to Vernier 2. So in the Vernier 2, so the 0th line of our Vernier scale is coincided to 220.5 degrees. 220.5 degrees. This is your MSR in the Vernier 2, and you can observe the 8th line is exactly coincided to any one line on the main scale. Here the Vernier coincidence is 8. So now the main scale is 220.5 degrees plus 8 minutes into least count. This is for blue color, both Vernier 1 and Vernier 2. So far we have taken the readings for blue color, both Vernier 1 and Vernier 2. Now I am going to adjust my vertical line of my crosswire to the green color. So in this way I need to adjust my vertical crosswire to the green color. So after adjusting with the help of your telescope, slowly you need to adjust your vertical line to the green color and note down the Vernier 1 and Vernier 2 readings in the spectrometer. See, now in the spectrometer with the help of telescope, you can able to see how the vertical cross wire is exactly coincided to green color in our VIBGYOR spectrum. So like that you need to coincide your cross wire to the green color and take the readings in the spectrometer both in Vernier 1 and Vernier 2. So you have seen the green spectrum coincidence in the telescope. Now we will take the readings for Vernier 1 and Vernier 2. So in the Vernier 1, MSR, so the 0th line of your Vernier scale is coincided to 39 degrees of your main scale. That means your MSR is here 39 degrees and Vernier coincidence is 4th line on the Vernier scale is exactly coincided to any one division on your main scale. So your Vernier coincidence is 4. So 39 degrees MSR and 4 lines is vernier coincidence into least count. That means 39 plus 4 into 1 minute. This is your vernier 1. Now let us go to vernier 2 for same green color. So now in the vernier 2, the 0th line is coincided to 221 degrees of your main scale. Hence the MSR is here 221 degrees and vernier coincidence is 16 minutes. See, the 16th line of your vernier scale is exactly coincided to any one line, some line on your MSR. So 16 is the vernier coincidence. So MSR is 221 degrees, vernier coincidence is 16. So MSR plus VC into least count. So this is your vernier 2. So similarly, we will go for next color, that is our yellow. So what we have to do here, the vertical line of your cross wire, you need to coincide exactly to your yellow color. So I am showing you on the book. Now we will see the same pattern in the telescope. The yellow color is now exactly coincided to vertical cross wire of our telescope. Now we have to take the readings. Same as usual, like vernier 1 and vernier 2. Vernier 1 and vernier 2 for yellow color. Now see the vernier 1 for yellow color. MSR is here 39 degrees. Same MSR. The 0th line of your vernier scale is coincided to 39 degrees of your main scale. Hence MSR is 39 degrees and vernier coincidence is 16 minutes. 16 minutes. The 16th line of your vernier scale is coincided to any one line of your MSR. Hence the vernier coincidence is 16. So 39 degrees plus 16 into least count. So now take the vernier 2 for yellow color. So the 0th line of your vernier scale is coincided to 222 degrees. 222 degrees. 222 degrees is the MSR and the 9th line is exactly, the 9th line of your vernier scale is exactly coincided to some line of our main scale. So 9 is the vernier coincidence. Hence 220 degrees is your MSR, 9th line is your vernier coincidence into least count. So like that you need to take the, you need to note down the vernier 1 and vernier 2 readings for various colors. So these are the readings which I have taken already. So this direct reading of V1 and V2, this direct reading is common for all the colors, and minimum deviation readings like vernier 1 and vernier 2 for blue, green and yellow colors. Now you need to calculate the DM, angle of minimum deviation. For that you need to do vernier 1 minus vernier 1 difference and vernier 2 minus vernier 2 difference. So by substituting V1 minus V1 dash, 180.4 degrees, 180.06 degrees minus 234.43. So V1 minus V1 dash is equal to 54.37. And similarly V2 minus V2 dash. So V2 is here 0.46 degrees minus 54.23. So you will get 53.77. Like that you need to subtract both V1 V1 dash and V2 V2 dash. Write down those values in the respective colors. Finally you need to take the average. This average is our minimum deviation angle. So by adding this difference and this difference divided by 2, you will get angle of minimum deviation. So you have now DM and we know the angle of prism is 60 degrees. You just substitute that A and D values in the refractive index formula. Mu is equal to sine of A plus D by 2 by sine A by 2. So A is here 60 degrees and dm is here 54.07 degrees divided by 2 into sin 60 by 2. So after simplification you will get the refractive index for blue color 1.678. Like that, by substituting all your dm and a values in the respective formula, you will get the refractive indices for green, blue and yellow colors like this: 1.678, 1.668 and 1.667. Now what is our final aim? Our aim is to calculate the dispersive power. Omega is equal to mu b. So any two colors in the spectrum, I have taken blue and green. Mu b minus mu g by mu minus 1. So mu b value from the tabular column 1.678 minus mu g value from the tabular column 1.668. And how to calculate mu? Mu is the average of these two colors. I have calculated here. The value is 1.673. So after substituting all the necessary values, I got the dispersive power 0.014. So this is our result. The dispersive power of the material of the given prism is 0.014. There are no units for measuring the dispersive power. Thank you.